Okay, students, so I'll just take half a minute to recap what we did in the last class before we can begin with today's class. Please let me know when my screen is visible to you. Is the screen visible?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Right.
ma'am.
Okay. So last time, if you remember, we started off with chapter number 2. We discussed what are multiplexers. Multiplexers, demultiplexers, encoders, and decoders, we had said, are some kinds of combinational circuits which are usually employed for data transmission, right? So after turning our attention to the adders and subtractors, we have finally started discussing the combinational circuits which are used for the data transmission, right? The first in these series that we are discussing is called a multiplexer, right? Or MUX in short. So we had seen the objective of a multiplexer, we had seen its block diagram and designed it from scratch. We designed a 4x1 multiplexer from scratch. We'd seen various applications where the multiplexers are deployed. And today, before I talk about a demultiplexer, I'd like to discuss certain applications, certain variants, I'd like to call it, of designing the multiplexers. Okay. So the first in this series, I'm going to take you to your book, to your textbook. Again, I request you to let me know when my screen is visible. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Right. Okay. The first thing that we're going to discuss today is how to design a quadruple 2x1 multiplexer. Okay, so the first thing is, obviously, you'd like to ask me, what do we mean by a quadruple 2x1 multiplexer, right? So we already know, we've already encountered this term earlier, that is a quad, right? If you remember, we said a quad means a set of
4.
four.
Four.
Four, right? So quadruple 2x1 MUX naturally therefore translates to 4 2x1 multiplexers built into one. Okay, so what are we going to see? We're going to see that instead of deploying 4 2x1 MUX, if I, for commercial usage, if I want to integrate them, okay, into one, then how can we do that? Okay, so obviously, let me see if I can draw something here. Otherwise, I'll have to take you to the PowerPoint again. Just give me a minute, please. Yeah. So thankfully, I have some tools here, I think. Right. So please see, if we had normal 2 cross 1 marks, how would it have looked like? Let us first look at that so that you're able to appreciate what you're seeing in the integrated picture. So what I'm drawing for you is a normal 2 cross 1 marks first of all. Okay. So obviously, as usual, two inputs. How many selection lines?
One. Yeah,
Yes,
ma'am. One.
good. And how many output lines?
Two.
How many?
Ma'am,
One,
one.
one.
One again, because a mux always has a single output line in any case, right? So, so, uh, please see that this is one such 2 cross 1 mux, right? So let this be the first mux. So how, what input lines will it have? Let's say A0 and B0. Okay, let's say A0 and B0. Are you able to understand
Yes,
what
ma'am.
is being written, right? And then I'll have a selection line, let's call it as S0, okay? And the output line, let's call it Y0, okay? So let us imagine four such 2 cross 1 muxes. The next one will have its input as A1, B1, right? S1 selection line, Y1 output, and so on and so forth. Okay. Now when I integrate all these four into one, you can see that this is gonna look like somewhere like this. So all the first four inputs are coming from the four multiplexers each. So these are the first input. This is the first input of the first mux, first input of the second mux, third input of the third, first input of the third mux, first input of the fourth mux, second input of the first mux, second input of the second mux, and so on. Is this clear?
Ma'am, will you please explain
Ma'am,
it?
please repeat.
Okay, that is why I was drawing this. Let me see if I can just draw at least one or two more of these. If only I could just get something to select this with. Let us see. Just give me a second, okay? Okay, so um, just draw it again. So please see that first mux has the first input as A0, right?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Right. And what would the second mux look like now? So the second mux would look something like this.
Ah,
It is not still not very convenient to edit a PDF, I think. Still, you know. Okay, so
ma'am.
yes.
Ma'am, I want to ask something.
Yeah, tell me with it.
Ma'am, this quadruple 2 cross 1 multiplexer is combining four 2 cross 1 multiplexers, right?
Right. Mm.
So, ma'am, I can see only 2 cross 1 multiplexers.
I'm just showing you. I'm just showing you. Just give me a second.
Okay, ma'am.
It's very inconvenient to draw here. Let me just show it to you in a PowerPoint slide. Okay. Okay, so this is the first input, right, of the first mux.
Ma'am, we cannot see your screen.
Okay, but in case my screen is not visible to you for 2 minutes, please let me know, okay? Just share the screen to you. Okay. Give me a second. Right. Can you see it now?
Yes, ma'am.
Yes, ma'am.
Right. So this is the first mux. Let us say giving us an output of y0 with a select line x0 and the inputs a0 and b0, right? Now, similarly, let us draw the other mux, other three mux. Right, this is the second mux. This is the third one. And this is the fourth one. Okay, so what are the inputs of the third mux? They will be
A2, B2.
A2 and
A2,
B.
B2, output is Y2, and the select line is named, let's say, S2, right? The input lines corresponding to the fourth mux are called
A3 beat.
A3.
select line S3 and the output line Y3. Okay,
Right.
so these are the four mux that we want to put together. Okay, so now what we have done is we've taken these first inputs of all the mux. Okay, right? And put them together like this. So what I have is A1, A2, A3, A4, right? The first input of each
Ma'am,
mux.
A0.
Yes.
Ma'am, it should be A0, A1, A2, and
Oh yeah,
A3.
yeah. I'm sorry. Yeah, yeah.
Excuse me, ma'am.
Yes.
Ma'am, does it mean that we are adding 2 into 1 mux?
Yes. Yes, beta. I just
Okay.
explained now what is the meaning of quadruple. I just said that quadruple means a set of four. So what we are going to do is we are going to take four 2 cross 1 muxes, okay, and for commercial purposes we would like to do what? We would like to integrate them and make it into a single circuit, okay.
Okay,
How do
ma'am.
we do that? Now what we are looking at, how could we do that? Okay, one possible way to of doing that is what we are trying to form. Is this okay?
Yes, ma'am. Thank
Right.
you.
Yeah. So what we have done is we have taken the first inputs of all the four marks. Any problem up till here?
No,
No,
ma'am.
ma'am.
Right.
No, ma'am.
And then the second inputs of all the four marks. Okay. Which are, please spell them for me.
B0,
B0,
B1,
B1,
B2,
B2,
B3.
B3.
Right. Okay. And the four outputs of one of each mux. Right.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Right. Please name them for me so that I can.
Y0, Y1,
First
Y0,
one would be
Y1, Y2,
right.
Y2, Y3.
Very good. Any problem up till now?
No, ma'am.
No. And then selection lines, right? Then the selection line.
Selection.
Now please see what is the difference between a see how many inputs does this mux have?
8.
8.
8. So what would be the difference between a 8 cross 1 mux and this mux that we have designed?
Ma'am, it
Ma'am,
has only one
in
select line.
yes, ma'am. In 8 cross 1, there will be 3 select
In
lines.
4 select
Yes,
lines.
ma'am. There are three
Three,
select lines.
sorry,
There
sorry,
will
three
be,
select lines will be there.
yeah. And in addition, how many outputs would be there?
Only one.
Ma'am,
Only
1.
one.
And here, how
Here
many
we have
outputs
4.
are there?
4.
4.
4.
4.
4.
Very good. Let's pause your discussion here, and I want to go back to the previous slide once more so that I can explain something else to you, right? So the first thing is you are able to understand the difference between a 8 cross 1 mux and a quadruple 4 cross 1 mux, right? Right. Now please see here. what happens is when I put S0 is equal to 0 in this particular mux, then what happens? Will somebody will somebody help me? Yes. What will happen when I put S0 is equal to 0 in this first mux? This is
Ma'am,
what I want to ask you.
first mux will get enabled, I guess.
Here about this.
A0 will be the output.
A0 will be
Yes,
output.
simple. A0 will be the output. That means A0 will be connected to Y0. Is that right?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Let us look at the second multiplexer now. Let us look at the second multiplexer now. So here, when I put S1 is equal to 0, what will happen? A1 will be
A1 will be
passed
the
on
output.
to,
Will be the output.
By one.
very good. And what happens when I put S1 is equal to 1?
B1.
B1 will be the
A0
output.
will be
V1 equal to
B1.
Y1.
Right. B1 is passed as the output to Y1. And so on, even for these two multiplexers, right?
Yes, ma'am.
Right?
Yes.
Now, please see what is the operation that should happen in a quadruple 2 cross 1 mux. So, if the first multiplexer was selected, okay, if the first multiplexer was selected and the select line had the input 0, then A0 would have passed on to Y0,
Yes, ma'am.
Yes, ma'am.
right? So whenever, okay, and what happens when I put S is equal to 0 in the second multiplexer? A1 should have been passed to Y1.
Yes, ma'am.
Yes, ma'am.
So in this quadruple 2 cross 1 mux, what should happen is that when I put S is equal to 0, okay, when I put S is equal to 0, let me just write it down for you to show you. Let's say this is the value of S. I'm putting here S, okay, and this is my output Y. This is my output. So when this is 0, what should be the output? Output should be all A0. When this is 0, the output should be A0 gets
A0.
connected to
A0.
Y0, A1
Y0.
to Y1, A2 to Y2, A3 to Y3.
I3.
So what is the output? The output should be all
A1.
AIs, right or not?
Yes, ma'am.
Yes, ma'am.
And when X is equal to 1, then the output should be
Yes.
all
BI.
BI.
So using a single selection line, what we have done is we have put all these 4 2 cross 1 muxes together, and how this quadruple 2 cross 1 mux is functioning, that whenever I give S is equal to 0, instead of one mux functioning, there are 4 2 cross 1 muxes that are functioning together now. Okay, and I get the output, the first output of all these 4 muxes together. Is this clear?
Yes, ma'am.
Yes, ma'am.
Any problem?
No,
No,
ma'am.
ma'am.
Right.
Excuse me, ma'am.
Yes.
And if we want y0 as 1 and y1 as 0, like different outputs, then what can we do?
Please come again.
Like in this case, you are saying that if we put s equals to 0, then y0, y1, y2, and y3 will be 0.
No, we did not say that. What did we say? Who would like to correct her?
Like we will get all AIs.
Yes. We
But if
don't
we
know what is the
if I
value
want
of, please see, we don't know what is the value of AIs. A0 may be 1, A0 may be 0. Similarly, for A1, A2, A3. Okay, I don't know what their values are. All I'm saying is whatever are their values will come as output whenever I give S as 0.
okay, ma'am.
Is this clear? Because
Yes, ma'am.
that is because this is the job of a multiplexer. Okay, this is the job of a multiplexer. Okay,
Yes, ma'am.
now please see, in the commercial circuits, sometimes there is also another input which is used, which is generally known as the enable input. Okay, so what this input does is it generally does the work of a power switch. Okay, it does the job of a power switch. Now, if this power switch is off, that means if this enable uh, input is 0, then nothing happens in the circuit. Nothing happens in the circuit. Okay, only when the value of E is 1, then the circuit will work. How do we write this? We say that whenever the value of E is 0, then I don't care whatever is the value of X, the output is all zeros. Okay? It is all zeros. That means the output is not considered to be valid. It should not be considered as valid. But when E is 1, then the normal function of the circuit will resume. Is this clear? So this enable input is not just for the for this quadruple 2 cross 1 mux that you're looking at on the screen, but this enable input you'll find at many places, okay, in many other circuits as well. Is this clear, students?
Excuse me,
Is
ma'am.
this clear?
Ma'am, is this enable input working like a key?
Like a,
Key, if it is open, then the circuit will work. If not, then no.
yes, exactly. It is working like a power switch. So the how what do? We can simply uh, you know give a 0 to this input and this circuit will switch off. Is this clear?
Yes,
That is a way to, that will be a way to power off this circuit. Is this clear?
Yes, ma'am.
Yes, ma'am.
Right. So this is the first thing that we wanted to see today. Let us look at another designing application of the multiplexers. So this time what we are going to look at is how to use two small multiplexers to build up a bigger multiplexer. Okay. Let me know when my screen is visible. Okay. Excuse me. So what we're going to do is we are going to use two 16 cross 1 muxes to build up a bigger multiplexer, which is a कितना बड़ा बन सकेगा by using two 16 cross 1 mux? Tell me.
4 cross 1.
What did you say? Sorry, I couldn't catch you. What is the next denomination of the multiplexer? I told you that we always design in the power of, the inputs are always in the power of
2.
Yes. So what will be the bigger multiplexer?
32 cross 1.
32 cross 1. So let us see how to build this multiplexer. To build such a multiplexer, we must first of all realize, please see, how many input lines will this multiplexer have? Should this multiplexer have? 32 cross 1 mux should have how many input lines?
32.
32.
32. Yes. Right? Is that clear to everybody?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
How many selection lines?
5.
5.
5.
Exactly. 5. Right?
Ma'am,
And how many output lines?
1.
1.
Only 1. Right? Now let us contrast this with a 16 cross 1 mux. So you can see a single 16 cross 1 mux here. So how many inputs will it have?
16.
16.
Starting from I0 up
I0
to
to I15.
0 to
I15.
I15.
I15. Yes. Right. And how many selection lines?
4.
4.
4.
4. Right. And how many output lines?
1.
1.
1.
So is that what you see on screen?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Even for this 16 cross 1 marks?
Yes,
Yes,
ma'am.
ma'am.
Very good. Now, how do we join these two multiplexers to create a bigger multiplexer? Okay. So one way is to employ a 2 cross 1 mux in addition to these two multiplexers. So for our ease of understanding, we are calling these inputs of the first mux as I0 to I15 and the inputs of the second mux numbered from I16 to I31. Is there any problem in this?
No, ma'am.
No,
Right.
ma'am.
Now, each of these multiplexers has its own selection lines, 4 as we had discussed, right?
Yes, ma'am.
Yes,
And
ma'am.
let us say their outputs are called O1 and O2. Any problem so far?
No, ma'am.
No, ma'am.
Ma'am,
Okay, but I have a
excuse
problem.
me,
I
ma'am.
have a problem. See, okay. So what is that problem? My problem is that these two multiplexers are there. These two multiplexers are there, and I can see that there are 32 inputs. Okay, but I want this complete unit to behave as a 32 cross 1 mux now. Although the fourth selection line is in place, right? The four selection lines are in place. How do I insert the fifth selection line and make it actually function like a 32 cross 1 mux? This is my problem, right? Is this clear to you? Is the problem clear to you?
Yes, ma'am.
Yes,
Yes.
Right,
ma'am.
Yes, ma'am.
right. So what we can do is, please see, if I employ this simple 2 cross 1 multiplexer here, okay, then I can feed in the outputs of both these multiplexers to this multiplexer, and the fifth selection line of the 32 cross 1 mux I feed to this multiplexer. Okay, right? So now what happens is that the fifth line, which is either a 0 or a 1, yes, this
Yes,
selection
ma'am.
line, if its value is 0, then this multiplexer gets selected. The output of this multiplexer will be passed on to the function. And if the value of this selection line is 1, then the output of this multiplexer will be passed on to the output. Is this clear? These,
Yes.
Yes, ma'am.
these
Yes, ma'am.
multiplexers are working normally. Okay. So if I have given 0, 0, 0, 0, 1, 0, then the third input line, which corresponds to I2, will be selected. Okay, right? And I have given a 0 here. So the complete thing becomes, I'll just write it down for you so that you can just make it out. Just give me a second. So just not able to write here. Let's say these are our selection lines S0. Let me make it simpler for you, even more simpler for you. Let us just take these four selection lines as 0. Okay, so now you will understand. If these four selection lines are 0 and this fifth selection line I'm giving as 0, okay, then what is the output that I'll get? I'll get I0.
0.
Is this clear? What is the output that I'll get? I'll get the output as I0. Clear?
Yes, ma'am.
This much is clear? If, however, I feed in 1 to this selection line, but the other 4 lines, please see, remain the same. Okay. Then what is the output that I'll get? This
I16.
multiplexer will be selected. The output
I16.
of this multiplexer will be selected. It will pass its zeroth output, which happens to be what? Which happens to
I16.
be
I16.
I16, right? So am I able to finally achieve the job of a 32 cross 1 MUX now? Can you see that?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes,
Is
ma'am.
this clear? So to a normal user, he is giving the value of 5 selection lines and he is getting one of the 32 outputs as usual, right? And these two multiplexers, there is no problem. They are working as usual by using the value of the 4 selection lines and simply passing on the corresponding input to the output. Any problem?
No, ma'am.
Good.
Excuse me, ma'am.
Yes.
Ma'am, why this one isn't combined like we saw in the previous one, in the 2 cross 1 quadruple? Why there are two 16 cross
Beta,
1?
they are not two 16 cross, they are combined only. Okay, just give me a second, right? Just give me 1 second, I'll show you.
Sure, ma'am.
So this complete thing is so now you can see that this is actually, this is supposed to be one unit. Okay, this is supposed to be 1 unit where what the user can see, he can only see the selection lines that he is giving. Okay, the inputs that he is giving, and the output that he is getting. Okay, so what he can see is this part. Please see. He can only see these inputs, okay, and the output. Okay, this entire thing is one, but we have used already manufactured two different 16 cross 1 MUX. We have, put them together. Okay, in the quadruple 2 cross 1 multiplexer that we had seen earlier, that was a integration of 2 cross 1 multiplexers on a single circuit. These are, however, this is a separate, this 16 cross 1 MUX is a separate component, completely functional in itself. This one is completely functional in itself. Different, you can say different blocks. Okay, so we have taken 1, 2, and 3 blocks and put them together now to make a bigger toy here. Okay, but in the quadruple 2 cross 1 MUX, the idea was not to take off the shelf 2 cross 1 MUX. Okay, so this is what you need to understand, that there the idea was, the question will tell you what is to be done. Please see what is the question here. Let us look at the question here. Two small multiplexers of same size can be joined. Please see, joined. Okay, and what is a quadruple 2 cross 1 MUX? Let me show you its definition. Please see here. In some cases, two or more multiplexers are enclosed within a single integrated circuit package. Please see. Can you see this?
Yes, ma'am.
Yes, ma'am.
The selection and the input enables in the multiple unit construction are usually common to all the multiplexers. Okay, so it just depends upon whether you want to implement it as a single circuit or you want to take off the shelf already working functional units and concatenate them together. That means join them together. They are different circuits, but you are just putting them together somehow to make them function as a bigger unit. What the user, however, sees is just the inputs and the outputs that he is getting. Is this clear? Is
Yes,
this
ma'am.
clear?
Thank you.
Yes,
Yes,
ma'am.
ma'am.
So this is the difference. Okay. I think it is time for the class already. It's 1 hour. So there is one thing more that I'd like to do with you tomorrow with respect to the multiplexers, and that is NAND gate implementation. So that is going to be an important thing that we're going to see, because although I'm going to share how to do NAND gate implementation for the multiplexer, but this NAND gate implementation, the way I will teach you, uh, can be used for any kind of circuit. Okay, so we are going to see that tomorrow, and after that, if time permits, we'll also take up demultiplexers tomorrow. Okay, so please try not to miss tomorrow's class. It will be uh, important as well, and I request you all to again please mark your attendance if you've not marked it so far. Okay. Okay, so Tisha is asking me, why is there no S0, S1, S2, S3? I think she was asking for the uh, quadruple 2 cross 1 mux. So as we've just read, beta, that if we are using the same circuit, then by definition it should have the